In this video, we are going to go over how to factor polynomials by grouping. In the last lesson, we learned how to factor using the GCF. If we look at this example, we quickly run into a problem trying to use the GCF. There is not a common factor that works for all four of these terms, so we need a new method of factoring. That is where this method called factoring by grouping comes into play. If you look at this in groups, and you look at that first set of terms, there is a common factor, and it would be an x squared. If you look at the second set of terms, there is a different factor that would work for those two. So we can tackle this in pieces. If we look at that first one, we already said our GCF would be x squared. So if we factor that x squared out, we end up with an 8x minus 9. If we look at that second set, we have a GCF of 2. So I can factor out a positive 2. And when we factor that out, that leaves us with an 8x minus 9. Now if you look at this, what should happen is these two pieces should be identical to each other if we did this correctly. So that essentially now becomes our common factor that we can factor out of these two terms. So we can factor out that 8x minus 9, and that's going to leave us with those two pieces that were left, the x squared plus 2, giving us our final answer of 8x minus 9 times x squared plus 2. When you work on your own for the homework and you check your answers with the answers provided, it might also show these in a different order. So if your answer looked like this, we know that's the same thing because the order in which we multiply does not matter. So either one of those would be acceptable answers. Let's look at another example. Here we have a 3m cubed minus 33m squared plus 2m minus 22. Again, if we look at all four terms, we do not have a common factor that works with all four terms. So we have to split this up and use our new method, factor by grouping. If we split them up, we can have a common factor in the first two and then a different common factor in that second set of two. Looking at that first set, 3m cubed minus 33m squared, we have a common factor of 3m squared that we can factor out of both of those terms, just like we did in previous assignments. That's going to leave us with an m minus 11. And then if we look at the second set, we have a GCF of 2. That we can factor out. If we factor out that 2, we are left with an m minus 11. And right here, again, these should be identical. They are. That becomes our new common factor that we can then factor out. So we have the m minus 11. That was the common factor we just divided out. And what was left? The 3m squared plus 2. Again, the order that you multiply doesn't matter, so I would also accept a 3m squared plus 2 being multiplied by the m minus 11. The order in which you multiply does not matter. Either of those would be correct. Let's look at a third example. Here we have 8x cubed minus 48x squared plus 3x minus 18. Again, we're going to have to group them to be able to pull out a common factor. If we look at the first set of 2, we have 8x cubed minus 48x squared. Our GCF would be 8x squared. So I can factor that out. That's going to leave me with an x minus 6. And of course my dog starts barking and ruins the video. Okay, sorry about that. I am back. No disasters, just an Amazon delivery guy the dogs decided was an intruder and didn't belong. I have no idea where we left off, so it looks like we just factored the first term, so we're looking for our GCF in the second term. Our GCF between a 3x minus 18 is going to be a 3, so we can factor out that plus 3, leaving us with an x minus 6. Again, what was inside those parentheses there should be identical. They are. That becomes our new GCF that we can factor out. So we have an x minus 6, and what was left, the 8x squared plus 3. Again, when you check your answer sheet on your homework, it might be listed in the other order, 8x squared plus 3, and then the x minus 6. But again, we know the order in which you multiply doesn't matter, so either one of those would be accepted. Let's look at one last example before you start practicing on your own. In this example, we have 77m cubed minus 70m squared minus 66m plus 60. So if we look at that first group of 2, and then the second group, we can go ahead and factor, because there is not a GCF that works in all 4 terms. In that first set of terms, we have the 77m cubed minus 70m squared. We can factor out the GCF of a 7m squared. And that is going to leave us with a m minus with an 11m, if I can focus, which apparently I can't after this knee procedure. So we factor out that 7m squared, so 77m cubed divided by 7m squared is going to give us an 11m, and then that negative 70m squared divided by 7m squared is going to give us a negative 10. Then if we look at that next term, I can't even talk, the next set of terms, the negative 66m plus 60, our GCF is going to be a negative 6. And when we factor that out, we end up with an 11m minus 10, which we have inside the parentheses the same thing. That becomes our new GCF that we can factor out, leaving us with the 11m minus 10 and the 7m squared minus 6. And for one last time of repeating myself, the order in which you multiply does not matter, so I would also accept if you have those in the other order, 7m squared minus 6, and then the 11m minus 10. The order in which you multiply does not matter, so I would accept either of those answers. Hopefully this helps get you started. Give it your best shot. I will be back next week to answer any further questions.